My name's Sean Sargent, as introduced. I'm the CEO of Green Lithium. And in a nutshell, this tells you what we're about. It's all about enabling our planet's transition to sustainable energy, and we aim to do that by providing low carbon lithium chemicals. So I'll start by describing the problem as we see it. So first of all, if you look at where lithium chemicals come from today, as we saw from Charles's graph earlier, it's very dominated by the Chinese market. So they come from two sources. They come from brines, predominantly from South America, but also from hard rock. At the moment, that hard rock is mined in Western Australia. It's exported to China, where the vast majority of the world's refineries are, before it goes into battery manufacture, can production, and so on. The way they do it is very high carbon dioxide. The grid mix in China has got a very high proportion of carbon emissions, and they use a lot of environmentally unfriendly processes in terms of the byproducts they produce and what they do with them. And of course, this is all set against a backdrop of a huge increase. Again, referring to one of Charles's slides, you saw that increase we're seeing, 406%. It was the biggest growth against a critical mineral is forecast in the lithium space. So, what we're specifically addressing is the European market. And this is compounded by a number of different factors. So first of all, the Paris Agreement, the fact that both the UK and the EU have made commitments to be net zero by 2050. And that means that we've got to go through the transition to electricity for transportation. It's one of the key tenets of how we're going to achieve net zero. So both the UK and the EU have announced bans on the sale of internal combustion engines after 2035. And what we've seen is the car makers have responded to that challenge. They've announced more than 400 new EV models, which are coming on the market as we speak. And of course, again, it's compounded again by the growth, as Charles said earlier, both in terms of grid storage, but also domestic storage batteries. And to some extent, these were unforecast. The rise in domestic take-up of batteries has taken everybody by surprise. But when you look at what that means for a European market, so we think, again, plumbing for the middle of the slide of the different forecasters, we think it's going to be between 600 and 800,000 tonnes per annum of battery-grade lithium chemicals per year in Europe alone, which is going to create this huge market. It's going to rise from about $1 billion per annum in 2022 up to $12 billion in 2030. But when you look at where that material is going to come from, there are currently no large-scale lithium refineries in Europe at all. When you look at where that bottleneck in the supply chain is going to come from, at the moment there's been a lot of discussion around spodumene. This is the mineral that goes into hard rock refining. Again, I mentioned it's currently all done in Western Australia, but there are mines being opened up. There's mines operating in Brazil now and in Canada, and we're seeing mines in development all over the world. So I think Brazil and Canada will start to compete with Australia. But we're also seeing the west coast of Africa, so places like Ghana, Namibia, also in Mali. We're seeing new lithium mines coming online, but also in Europe. So Portugal, Austria, Finland are all seeing production. So actually increasingly, as we get towards 2030, most of the forecasters predict that there'll be a surplus in spodumene. And actually the real bottleneck, so the right-hand curve shows you the position in Europe in particular. Even if all of the lithium refineries that are in planning or development at the moment come to fruition, there's still forecast to be a 43% undersupply in that market. So there's a real bottleneck in the refining, and to some extent this hasn't been realised by many people. And I think some of that capital raising question, this is a really interesting point, that why hasn't there been more attention in this area? So just to give you a bit of an overview of what our business model is. So first of all, we're a merchant refinery, which means we can work with any mine in the world. We'll be buying unrefined spodumene concentrate, initially from Western Australia, but the ultimate plan is to bring that much closer to home. The plan is to build, first of all, a scale-up plant. This is about de-risking the full-scale plant. It's about developing operational capability and demonstrating that capability to stakeholders. And then a second plant, the full-scale plant, which has two lines, each capable of producing 25,000 tonnes per annum. Our immediate downstream customer will be the cathode producers. So these are the people who take the nickel, the manganese, the cobalt, they build it into the cathode, which is the positive end of the cell, before that cathode then goes to the cell manufacturers and put together. And the cell manufacturers are the gigafactories that we do hear an awful lot about. That 50,000 tonne per annum figure for the full-scale plant, even though this is a large refinery, it's still only 6% of that European demand by 2030. And to give you a bit of context, that's about 1.2 million electric vehicles per annum. There's three things about green lithium which are unique in the market. The first is this idea about moving through a scale-up plant, an intermediate scale plant, to develop the capability. We appreciate that building a plant outside of China, where all the capability exists today, is going to have challenges. So the plan is to build an intermediate scale plant quickly, to develop that capability, and then we're ready for the full-scale plant and moving into that. The second point is about being low carbon and sustainable. So we know that by using various measures like hydrogen instead of natural gas, renewable electricity instead of carbon or gas-fired electricity, by using carbon capture, by using energy recycling, by localizing the supply of our raw materials, we can produce lithium chemicals far, far lower than the average in the market today. We also plan to do it in a sustainable way, which means we don't want to have any waste products from our process. So the primary co-product we produce is an inert sand that's got certain properties, and we've been doing a lot of research with the University of Sheffield to look at byproduct reuse, if you like. So the co-product we're looking at is a cementitious material, and we've got a patent application that's being processed as we speak. And that's our way of ensuring that we everything that comes to the UK into our refinery finds a use which is decarbonising other industries in some form or another. And then finally, the people we've assembled in our team, these are people who've got experience and knowledge of delivering first-of-a-kind process plants in the UK within our regulatory environment. That comes with a bucket of risk. We're employing people who understand how to mitigate those risks and manage those risks and provide surety around delivery. I mentioned about the low carbon aspect. So one of the very first things we did was had an independent carbon life cycle assessment produced to benchmark ourselves against a classic Chinese refinery. And when you look at how our refinery sits in the range of refineries that are in operation today, we're confident that by 2035 we can get down to about 75% of the carbon footprint of one of those refineries through the measures I talked about. You know, the last of those around localizing supply chain, that relies on mines coming online closer to home so we can reduce that final 10% around that shipping leg. The process selection is a really important aspect of this. The first 25% of that carbon reduction comes from selecting a different technology. So instead of using the acid leach, as is used exclusively in Chinese refineries and in the two refineries that have been built in Western Australia, we're going for an alkali leach process. So it's a much more selective process. It's got a lower energy footprint, which is where we get the carbon dividend, but it's also more selective in terms of extracting the lithium chemicals. So you've got far less polishing to do before you can reach that battery grade quality material. We're planning to build the plant in the UK, and we often get asked, why are you building in the UK? We think actually the UK is an exceptional environment for a production facility at the moment. First of all, there's no political barrier to us supplying either Europe or the United States. So the Atlantic Declaration meant we were brought into the fold of the Inflation Reduction Act, which means our material will qualify for the tax incentives that are available if they go into a battery in the United States. And in terms of our relationship with Europe, so there are no bars in terms of rules of origin or anything else to our material going into Europe. In the UK, we've got quite an unusual way of incentivising businesses to make low carbon, both electricity but also hydrogen. And what that means is through the Contract for Difference scheme is we'll be able to buy hydrogen in Teesside for the same price as natural gas, which means we get that carbon reduction dividend without an increased price point. I'm not aware of anywhere else in the world where you'd be able to set up a plant of this scale and receive that kind of benefit. The UK Infrastructure Bank, it's a government-backed bank that's been set up. Initially, they were looking at providing debt finance, government-backed debt finance to projects like ours. They've got several criteria that they use to assess whether or not they're going to support a project. We support 3 of the 5 criteria, so they're very interested in our project. More recently, they've stepped into providing equity support to projects. So trying to crowd in equity investors to a project like ours, they'll now participate in large equity fundraisers. And finally, the Automotive Transformation Fund. So they've been a great supporter of the project until now. They provide grant support from anything from early feasibility through project development, right the way through to CapEx support to construction. We're planning to build the site in Teesside, and again, there's a great list of benefits to building the plant in Teesside, which make it really attractive to us. The first of those is it's a decarbonised industrial cluster, which means there's lots of hydrogen development going on, which is how I've got confidence that we'll be able to use hydrogen instead of natural gas to power the plant in time. But it also means there's carbon capture available. It means that you've got renewable energy plentifully available. So it's a decarbonised cluster that really supports our aims and objectives. The second one is the site we're on. So our landlord is PD Ports. They own and operate Teesport, which is a deep water port. It does bulk handling, so we can import those raw materials from anywhere in the world in very large vessels if we can. And they've also got a container terminal immediately adjacent to our site. So it avoids that double handling. Once we make our product, we can get in a container heading to anywhere in Europe within 24 hours using those daily shipping routes. PD are also very closely aligned to us. They've got a very similar plan for decarbonisation of their own operations. So we find that there's huge synergies between what we're trying to do and what they're trying to do. The next aspect is around support from local authorities. So we've got our planning permission. We got it incredibly quickly, and that's because the local authorities in Teesside are desperately keen to see new industry coming to the area and bringing 21st century green jobs. So they're very supportive. If you want to make a change to the planning process, they're incredibly flexible, and we've enjoyed huge benefits following our initial public consultation. And as I say, we've achieved that planning permission in pretty much record time. And then most of all, probably most importantly, we know we're going to need a lot of operators who are used to working in process industries, used to working with processing minerals. And of course, in Teesside, it's got a rich heritage in steelwork, which requires many of the very similar skills to what we're trying to do. And that gives us a pool of people who are trained. We can retrain them in hydrometallurgy, pyrometallurgy, the very specific skills we need. But having a pool of people we can tap into brings huge benefit to us, but also huge benefit to the area. It's an area with some of the highest unemployment in the UK. Now, this complicated slide, I'll try and talk you through it, but it gives you an idea of what we're planning to do and why we're planning to do it. So the top line there, the scale-up plant, this intermediate size plant that we're planning, we're currently in the design phase. Once we get to the CapEx fundraise, it's about an 18-month construction and commissioning program. So by the end of next year, we'll be entering into production. The whole point about that is to de-risk the full-scale plant. So we know that the large full-scale plant, it's a billion-dollar plant, so we know that's going to have a lot of inherent risk as we both commission and ramp up that operation. So the whole point about the scale-up plant is developing the operational capability, doing the problem-solving, ready for that full-scale plant. So if you look at the graph at the bottom, the orange line shows what the risk profile for the project looks like if we don't build a scale-up plant. We carry that risk all the way through to ramp up on the full-scale plant, and then we solve those problems in a very painful short duration period, which could be 1 or 2, maybe 3 years. But with the scale-up plant, we tackle some of those biggest risks head on. We tackle them quickly, and then it's just a question of scale. It's applying those lessons and those capabilities for the full-scale plant. So then the plan is to build lines 1 and 2 of the full-scale plant. That's the 50,000 tonnes per annum, the 6% mark. The site's big enough for a third line. And we've not declared our plans for the third plot yet, but it could either be another line at 25,000 tonnes per annum, or we might look to be re-refining lithium chemicals that have been extracted from recycled batteries and using a subtly different technology to do that. And then finally, we think this model is deployable. The model of stepping through a scale-up plant to a full-scale plant means we can go to jurisdictions where there's no lithium refining today and develop a capability in a similar way. So we think there's a real model around global growth, and we've actually already done some work assessing the primary candidates for where that second jurisdiction would be. We spent about £14 million to date. About a third of that came from government grants. The other 2/3 came from private equity raises. And I'll just pick out some of these very quickly. So we did bench scale trials for our technology, this alkali leach process I mentioned. We then scaled those up to pilot scale trials to make sure you could get the repeatability of the yields. We got some really exceptional results, which we were really pleased with. We've done various other things. I mentioned the carbon life cycle assessment. We've initiated the front-end engineering design. line. And then probably most importantly, it's all around those supply and offtake discussions. So building those commercial relationships, both with the suppliers to the plant all around the world, but also the people in Europe who are going to be buying these chemicals. Thank you.